Right now, coal and charcoal feel like such basic, almost primitive fuel sources that it's easy to overlook just how significant their original discovery actually proved to be for early human technological development. Long before modern industrial coal mining, ancient humans had already figured out how to identify, produce, and effectively use these two related but distinct carbon based fuel sources, each opening up entirely new practical possibilities. Let's dig into this properly, because charcoal and coal actually represent two truly different discoveries with two seriously different historical timelines, each worth exploring specifically in its own right. Let's start with charcoal, because humans almost certainly discovered and began using charcoal considerably earlier than coal specifically. Charcoal production involves heating wood in a low oxygen environment, driving off water and various other volatile compounds while leaving behind a considerably purer, more concentrated carbon material capable of burning at meaningfully higher temperatures compared to ordinary wood. Early humans likely discovered charcoal's basic properties somewhat accidentally, connected directly to their already well established use of controlled fire, since partially burned wood recovered from a smoldering, oxygen limited fire would naturally demonstrate at least some of charcoal's distinctive burning characteristics compared to ordinary untreated wood. This detail matters considerably for understanding why charcoal specifically developed so early within human technological history. Rather than requiring some kind of complex, deliberately engineered discovery process, charcoal's basic properties would have been at least partially observable through ordinary, already established fire use, meaning early humans likely gradually refined their understanding of charcoal production through accumulated practical experience rather than through any single, sudden moment of deliberate invention. Let's talk about how deliberate charcoal production actually developed and became increasingly refined over time, too, because this represents an important, closely related developmental process worth exploring in additional depth. Early humans eventually developed deliberate charcoal production techniques, constructing specific earthen mounds or pits designed to allow wood to smolder in a carefully controlled, oxygen limited environment, producing considerably more charcoal and considerably more consistent, higher quality charcoal compared to whatever charcoal might occasionally form as an incidental byproduct of ordinary fire use alone. This deliberate production process required considerable accumulated practical knowledge regarding exactly how to properly construct and manage these specific charcoal production structures, representing a genuine technical skill that experienced charcoal producers developed and refined across many successive generations. Let's talk about why charcoal proved so significant for subsequent early human technological development too, because this represents an essential dimension worth exploring specifically. Charcoal burns considerably hotter than ordinary wood, providing the higher temperatures necessary for successfully smelting metal ores, connecting directly to broader questions already explored extensively in other discussions regarding early human metalworking technology and its historical development. Without reliable access to charcoal specifically, early metalworking technology, including the development of bronze and eventually ironworking, likely wouldn't have been practically achievable, meaning charcoal's earlier discovery and refined production represented an essential technological precondition supporting numerous subsequent significant developments throughout ancient human technological history. Let's talk about specific archaeological evidence for ancient charcoal production facilities too, because grounding this discussion in concrete examples helps illustrate the actual technical sophistication ancient charcoal production eventually achieved. Archaeologists have identified numerous ancient charcoal production sites across various regions, including specific earthen mound structures and pit kilns showing clear evidence of deliberate, systematic charcoal production rather than incidental byproduct formation, with some sites showing evidence of large-scale, sustained charcoal production operations, clearly organized to supply nearby metalworking or other significant fuel-intensive craft activities. This detail reinforces an important point worth appreciating throughout this entire discussion. Charcoal production eventually developed into a truly specialized ancient craft and profession in its own right, requiring dedicated practitioners possessing considerable accumulated technical knowledge regarding exactly how to successfully manage this particular controlled, low-oxygen wood processing technique. Let's talk about peat as a closely related, sometimes overlooked ancient fuel source too, because this represents an interesting complementary dimension worth exploring specifically before continuing this broader discussion. Various ancient societies inhabiting regions with abundant peat bogs, particularly across parts of northern Europe, developed practices for harvesting and using peat, partially decomposed organic material formed within waterlogged bog environments, as an alternative fuel source in regions where wood or coal weren't necessarily as readily, locally available. This detail is worth including because it demonstrates that ancient fuel technology extended beyond simply the two primary fuel sources already discussed extensively throughout this topic, with different ancient societies developing practical fuel solutions specifically suited to whatever natural resources happened to be most readily available within their own particular local environment and region. Let's talk about the specific chemistry distinguishing charcoal from coal, too, because this represents an important, scientifically detailed clarification worth exploring in additional depth. While both charcoal and coal represent carbon-rich fuel sources capable of burning at meaningfully higher temperatures compared to ordinary wood, they differ considerably in their specific chemical composition and formation process, with charcoal representing a relatively pure carbon material produced through deliberate human processing of wood specifically, while coal represents a naturally occurring mineral formed through geological processes acting on ancient plant material over an enormously extended time frame, generally containing various additional mineral compounds beyond pure carbon that charcoal typically lacks. This distinction matters considerably for properly understanding why these two related fuel sources developed such different historical usage patterns and why researchers can reliably distinguish between them when examining ancient archaeological fuel residue and ash deposits. Let's talk about health effects ancient populations likely experienced from sustained coal and charcoal use too, because this represents an important, often overlooked dimension worth exploring specifically before wrapping up this broader discussion. Sustained exposure to smoke from both charcoal and coal combustion, particularly within poorly ventilated ancient indoor spaces, likely produced measurable negative health effects for ancient populations regularly exposed to this smoke. Connecting directly to broader questions, researchers continue actively studying regarding historical indoor air quality and its documented health consequences throughout much of human history. This detail is worth including because it adds important additional nuance to this broader historical story, acknowledging that these seriously valuable ancient fuel technologies, despite their significant practical benefits already discussed extensively throughout this topic, likely also carried genuine health costs for the ancient populations who relied upon them so extensively across many centuries of continued practical use. Let's talk about how charcoal specifically enabled early pottery and ceramic technology too, because this represents another significant practical application worth exploring in additional depth, extending beyond the metalworking application already discussed extensively earlier throughout this topic. Charcoal's ability to reach and sustain higher, more consistent temperatures proved essential for successfully firing pottery and ceramic materials at the specific temperatures required to produce really durable, functional ceramic objects, connecting directly to broader questions already explored extensively in other discussions regarding early human ceramic and pottery technology and its historical development. This additional application reinforces just how foundational charcoal's early discovery and development actually proved to be, supporting multiple significant, independently important categories of subsequent ancient technological achievement beyond metalworking alone. Let's talk about regional variation in ancient coal accessibility and its effect on different civilizations' technological development too, because this represents an interesting, closely related geographic consideration worth exploring before continuing this broader discussion. Regions with abundant, easily accessible natural coal deposits, including certain specific regions of ancient China already discussed extensively throughout this topic, developed correspondingly more extensive coal use traditions compared to regions lacking this particular natural resource, illustrating how directly ancient technological development frequently depended on locally available natural resources, a pattern already explored extensively throughout numerous other discussions regarding ancient human technology and its close connection to specific regional, environmental, and geological circumstances. Let's talk about coal specifically now, because this represents a really different fuel source with its own distinct discovery and developmental history worth exploring separately. Unlike charcoal, which humans actively produce through deliberate wood processing, coal exists as a naturally occurring mineral resource, formed over an enormously long geological time frame through the gradual compression and transformation of ancient plant material. This detail matters considerably for understanding coal's different discovery story, since humans didn't need to develop any kind of production process to access coal, but rather needed to identify naturally occurring coal deposits and recognize their practical value as an effective, burnable fuel source. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. Let's talk about when humans first began using coal specifically, because this represents an important, historically documented timeline worth exploring in additional depth. Archaeological evidence confirms humans began using coal as a fuel source at various different points across different regions, with some of the earliest confirmed evidence coming from ancient China, where researchers have found evidence of coal use extending back several thousand years, considerably predating coal's much later, more famous large-scale industrial application already explored extensively in other discussions regarding industrialization's historical development. This detail is worth appreciating because it directly counters a common, persistent misconception treating coal use as an essentially modern, purely industrial era phenomenon. Ancient humans had already discovered and begun practically utilizing naturally occurring coal deposits many thousands of years before coal eventually became so dramatically significant during considerably more recent industrial history, representing a considerably longer, more gradual historical relationship between humans and this particular natural fuel resource than popular assumption might otherwise suggest. Let's talk about how ancient humans actually identified and located usable coal deposits too, because this represents an important, practically relevant consideration worth exploring specifically. Coal deposits frequently become visible at Earth's surface through natural erosion processes, particularly along exposed cliff faces, riverbanks, and other locations where natural geological processes had already exposed underlying coal seams without requiring any deliberate human excavation effort. This detail helps explain how ancient humans likely first discovered coal's existence and practical burnable properties. Encountering naturally exposed coal deposits through ordinary environmental exploration and observation, before gradually developing more deliberate methods for identifying and eventually extracting additional coal from less immediately visible underground deposits. Let's talk about how ancient coal use actually differed from charcoal use in terms of specific practical application too, because this represents an important distinction worth exploring before continuing this broader discussion. While ancient coal use certainly occurred as already established extensively throughout this topic, it generally remained considerably more limited in overall scale and geographic distribution compared to charcoal use throughout most of ancient and early historical human history, likely connected to coal's less universally accessible natural distribution compared to wood. The raw material charcoal production specifically requires, which remained considerably more widely, consistently available across a broader range of different ancient human settlements and regions. Let's talk about how ancient societies actually extracted coal once naturally exposed surface deposits proved insufficient too, because this represents an interesting, more technically demanding dimension worth exploring specifically before wrapping up this broader discussion. As ancient coal use gradually expanded beyond simply collecting naturally exposed surface deposits already discussed extensively throughout this topic, certain ancient societies developed more deliberate extraction techniques, including basic surface mining methods specifically designed to access coal seams located just beneath the immediate surface, representing an important technical precursor to the considerably more elaborate underground mining operations that would eventually develop during later historical periods. Particularly connected to the large-scale industrial coal mining already explored extensively in other discussions regarding industrialization's historical development. Let's talk about specific cultural and religious attitudes ancient societies sometimes held toward these particular fuel sources too, because this represents an interesting, closely related cultural dimension worth exploring before this discussion concludes. Various ancient cultures developed specific cultural or religious significance connected to fire and combustion more broadly, sometimes extending to particular attitudes or practices surrounding charcoal and coal specifically. given how directly these particular fuel sources connected to fire itself, an element carrying significant religious and cultural importance across numerous different ancient societies and belief systems. This detail is worth including because it reinforces a familiar pattern already explored extensively throughout other topics regarding ancient technology. Practical, everyday materials and technologies frequently carried additional cultural and symbolic significance extending well beyond their purely functional application alone. Let's talk about how modern chemical analysis techniques have specifically advanced researchers' understanding of ancient fuel use too, because this represents an important, technically sophisticated methodological consideration worth exploring in additional depth before wrapping up this broader discussion. Contemporary researchers studying ancient fuel residue increasingly rely on sophisticated chemical analysis techniques capable of identifying the specific chemical signatures distinguishing charcoal ash from coal ash, and even in certain cases identifying the specific type of wood originally used to produce a given ancient charcoal sample, allowing researchers to construct an increasingly detailed, increasingly precise picture of ancient fuel use patterns extending well beyond what simple visual archaeological examination alone could ever have reliably confirmed and established. Let's talk about how these ancient fuel discoveries specifically connect to broader questions regarding early human technological innovation more generally, too, because this represents a fitting unifying point worth exploring before this discussion concludes. Both charcoal and coal's historical discovery and development reinforce a broader pattern already explored extensively throughout numerous other discussions regarding early human technology. Significant technological advancement frequently emerged from careful, patient observation of naturally occurring phenomena, gradually refined through accumulated practical experience across successive generations, rather than representing sudden, isolated moments of deliberate invention, disconnected from this broader pattern of gradual, cumulative technical development and refinement. Let's talk about how researchers actually study and confirm these various ancient fuel use histories too, because this represents an important methodological consideration worth addressing directly. Researchers rely on archaeological evidence, including preserved charcoal remains and ash deposits found at ancient settlement and metalworking sites, alongside direct evidence of ancient coal use, including coal fragments and ash residue showing coal's distinctive chemical composition compared to wood-based charcoal ash, allowing researchers to confidently distinguish between these two related but chemically distinct ancient fuel sources and trace their respective historical usage patterns with considerable scientific precision. Let's talk about specific ancient civilizations that particularly relied on and developed sophisticated coal use too, because this represents an interesting, more specifically documented dimension worth exploring in additional depth. Beyond the early Chinese coal use already discussed extensively throughout this topic, archaeological evidence confirms various other ancient civilizations, including certain Roman settlements in Britain, also made meaningful use of locally available coal deposits, sometimes specifically for heating purposes and various craft applications, demonstrating that ancient coal use, while certainly less universally widespread compared to charcoal, still developed independently across multiple separate ancient civilizations wherever naturally accessible, coal deposits happen to be locally available. Let's talk briefly about specific temperature requirements. Different metalworking processes actually needed too, because this represents a fitting, technically grounded detail worth including before this discussion concludes. Successfully smelting different metals required reaching specific minimum temperatures, with early copper working requiring temperatures considerably below what iron working eventually required, meaning charcoal's gradual technical refinement and increasingly efficient production developed and improved across successive generations already discussed extensively throughout this topic, directly enabled the historical progression from earlier, lower-temperature metalworking traditions toward the considerably more technically demanding iron-working traditions that eventually developed later in ancient technological history, connecting charcoal's own gradual technical refinement directly to this broader, historically significant metallurgical progression. Let's talk about how charcoal specifically remains in active, meaningful use even within our current modern world, too, because this represents a fitting way to draw this discussion toward its conclusion. Despite the enormous technological changes separating ancient charcoal producers from contemporary society, charcoal continues serving genuine practical purposes even today, including everyday backyard grilling, various specialized industrial applications, and certain traditional metalworking and craft practices that continue deliberately using charcoal specifically for its particular combustion properties, representing a remarkable, direct continuity connecting ancient charcoal production techniques first developed many thousands of years ago, directly through to contemporary practical use occurring in ordinary households and specialized craft workshops even today. Let's zoom out and pull all of these different threads together, because the full story of how ancient humans first discovered coal and charcoal turns out to represent two truly distinct historical developments, worth appreciating separately rather than collapsing into a single, simplified narrative. Charcoal likely developed gradually through early humans' already established relationship with controlled fire, eventually becoming deliberately, systematically produced and proving essential for enabling subsequent metalworking technology, while coal represents a naturally occurring mineral resource that various ancient civilizations independently discovered and began utilizing many thousands of years before coal's, much later, considerably more famous industrial era significance. So the next time coal or charcoal comes up in conversation, whether connected to backyard grilling or historical industrial development, it's worth appreciating that both fuel sources actually carry considerably deeper, considerably more ancient historical roots than popular assumption typically suggests, representing genuine ancient technological achievement worth appreciating in its own right. Which leaves an interesting thought worth sitting with. If something as seemingly modern and industrial as coal actually turns out to have been discovered and practically utilized by ancient humans many thousands of years earlier than popular assumption typically suggests, what does that indicate about how frequently modern popular imagination might be underestimating just how far back many seemingly modern technologies and materials actually trace their genuine historical origins?